Welcome to Signals and System subject classes. Now we are in the fifth chapter, that is continuous time Fourier transform. So this is the fifth video. So previously we have discussed Fourier transform for the period signal. Here I would like to write Fourier transform for the periodic and aperiodic in one place. So Fourier transform for the, so here I'm going to write formulas for the Fourier transform for periodic and aperiodic in one place. So Fourier transform. So in first case, we will see periodic signal. So periodic. So for the how to write for periodic. So first I'm taking one periodic signal like this. So it's a Fourier series representation. So this is the column for the x of t. So this is x of t, and this is Fourier transform. Fourier transform, and this is column for the Fourier series coefficient AK. So in for the first, for example, one periodic signal, that is x of t, so sigma ak into e power jk omega naught into t k from the minus infinite to plus infinite. So this is a periodic signal. So its Fourier series is ak for all. For that, the Fourier transform, that is 2 pi sigma ak into del of omega minus k into omega naught k from the minus infinite to the plus infinite. So these are periodic signals. Periodic signals. So this is the one case. Another periodic, already we have done that. That is e power j into omega naught into t. E power j omega naught into t. Already we can derive this formula for with the help of this one, and also in previously with the help of the frequency shifting also we can solve this. So e power j omega naught t, its Fourier transform equal to 2 pi into, so one Fourier transform equal to del of omega. So here e power j omega naught is multiplied for the frequency shifting. So similarly cos omega naught t, already we derived that equal to pi. So del of omega minus omega naught. In last class we discussed about this one, del of omega plus omega naught. Then sine omega naught t, so Fourier transform pi by j del of omega minus omega naught minus del of omega plus omega naught. So what are the Fourier series coefficient ak values? See, this is it is having only one exponential, so this k equal to 1. Then so a1 equal to 1. Its coefficient the magnitude equal to 1. For in this case a1 equal to a minus 1 equal to 1 by 2. In this case a1 equal to minus a minus 1 equal to 1 by 2j. This is Fourier coefficient. Similarly, for the one, so for one, what is the Fourier transform? That equal to 2 pi into del of omega. We done this with the help of the duality property, and also we can find the this is the period signal. Then we can also with the help of this one also we can do that. So for this case, the Fourier coefficient a naught. So a naught is a naught equal to 1. Otherwise, ak equal to 0, k not equal to 0. Is it k not equal to 0? The coefficient equal to 0. So this is the formulas for the periodic, and you know that period signal, rectangular pulse period signal, that is x of t, x of t 1 from the mod t less than t1, and from the t1 to the half of the time period. So this is a rectangular pulse periodic signal. So you know that AK formula, AK equal to 2 into sine k omega naught into t1 by k omega naught into t. For this case, just substitute AK value. Here I'm not writing AK directly, just substitute AK. So I'm not substituting that value, just writing AK into del of omega minus k into omega naught. The k from minus infinite to plus infinite. So this is a periodic signal. One more periodic signal, that is impulse train. Impulse train, that is x of t, that equal to sigma del of t minus n into capital T. For every time period, impulse will be repeated. So n minus infinite to the plus infinite. For this case, the Fourier coefficient AK value already we have done in the case of the Fourier series, continuous time Fourier series, that AK equal to 1 by t. Then substitute AK equal to 1 by 2, 1 by t. So that equal to 2 pi by t, 2 pi by t sigma del of omega minus k into omega naught into k equal to minus infinite to plus infinite. See here, the signal in time domain is an impulse train. So in frequency domain also, the signal is a impulse train, is it? The Fourier transform of the impulse train becomes also Fourier transform, but the magnitude equal to 2 pi by t. Here, the magnitude equal to 1. That is a difference. So you should remember. So Fourier transform of the impulse train also impulse train. This is the case. So now we go for the periodic signal. No, aperiodic signal. Sorry, aperiodic signal. So aperiodic signal. So that aperiodic signal, I'm taking this. This is rectangular pulse. On the rectangular pulse, x of t that equal to 1 for mod t less than t1. For the mod t greater than t1, there is no signal. Is it rectangular pulse only? It is having magnitude from the t minus t1 to the t1. For that Fourier transform, x of j omega that equal to just, you know that x of j omega is nothing but ak into t, and k omega naught must be multiplied by the omega. That's it. So that equal to 2 into sine omega t1 by omega. So this is a Fourier transform for the rectangular pulse. Omega is a variable, and in rectangle. So this is a sinc function, is it? Rectangle from Fourier transform is sinc, and in here I'm taking the in frequency domain is a rectangular pulse that equal to 1 for omega mod omega it's less than W, and 0 for mod omega greater than W. For this case, inverse Fourier transform that x of t equal to sin Wt by pi t. This is the inverse Fourier transform. So rectangle pulse Fourier transform is sinc function, and sinc function Fourier transform is the rectangle pulse. So duality property. Next one. So we know that del of t. So del of t, it's a Fourier transform equal to here. I'm writing this del of t Fourier transform equal to 1. We know that. So next del of t minus t naught. So time shifting property. So 1 into e power minus j omega into t naught. Time shifting property. So what is the Fourier transform for the u of t? U of t from the Fourier transform formula, we got the u of t Fourier transform equal to 1 by j omega. But with the help of the properties, we will get like this. For example, so this is very very important. It's very very important. So, mm, so with help of the integration property, so u of t we can write integral of dou by tau into d tau minus infinite to the t. So integration property, here I'm writing integration property. For example, integral x of tau into d tau minus infinity to tt, it's Fourier transform. This is called integration property. Integration property. So that equal to x of j omega by j omega plus pi into del of omega into x of 0. Simple. So u of t, it is the integration of the impulse. So here the x of t equal to del of t. Then, so u of t equal to integral of minus infinite to the t del of tau into d tau. So Fourier transform. So it's Fourier transform. This is continuous time Fourier transform. Continuous time Fourier transform. Here x of tau Fourier transform is x of j omega. So del of t Fourier transform equal to 1. So 1 by j omega. Same should follow this formula. So x of tau. So if here we take x of j omega, x of j omega is nothing but Fourier transform of the x of t. Here del of t Fourier transform equal to 1 plus pi into del of omega. See the x of j omega equal to 1. So automatically x of 0 also 1, is it? So this is the Fourier transform of the Fourier transform of the um, unit step function. So this is so continuous time Fourier transform that equal to what we are getting here 1 by j omega pi into del of omega. So this is the case. So here I'm going to write one question. He may ask you. question like this. Question in examination, in multiple choice question. E of t is a continuous time, unit step, signal. Then what is the Fourier transform of Fourier transform of E of t? Options are option A 1 by j omega, option B 1 by a plus j omega, option C 1 by j omega plus pi into del of omega, option D 1. Is it? So, in initial stage, from the Fourier transform formula, we got the answer 1 by j omega. But from the integration property, relation between the unit step and impulse, we are getting 1 by j omega plus pi into del of omega. So, for the case, you should select the option C. C is the correct answer. If it is not given in the question options, then you should select this one. For example, there is no given this option. For example, here given like so del of omega only given. So del of omega. Option A 1 by j omega, second one 1 by a plus j omega, the third one is del of omega in 1. For this case, you should select this one. If these two are given, so but you should select this option. This is the correct. So this is very, very important. Try to remember. So next one, Fourier transform of the e power minus at into u of t. So its Fourier transform equal to 1 by a plus j omega. Is it? Then see here. Now t into e power minus j omega. Sorry. E power minus a into t into e of t Fourier transform is what? See, this is the, we should go to write the Fourier transform for this one. You should get it from the differentiation in the frequency domain. That is here, I'm going to write here the property. See, this x of t, its Fourier transform equal to x of j omega. Then, so t into x of t is Fourier transform that equal to, so that Fourier transform equal to j into d by d omega into x of j omega. So this is the property. So continuous time Fourier transform, continuous time Fourier transform. So x of t is multiplied by t. Whenever x of t multiplied by t, then you should do the differentiation to the frequency domain and multiply with the j. So this is the case. Already e power minus 8 u of t Fourier transform, we know that equal 1 by a plus j omega. Then, so the answer is here j into d by d omega into x of j omega. So what is the x of j omega? Here the x of t is e power minus 8 u of t. It's x of x of j omega is 1 by a plus 1 by a plus j omega. So what is the answer? Differentiation. So can do the u by v. Yes, in the u by v, we know that u by v. So a plus j omega square by and a plus j omega and differentiation of the numerator that equal to 0 minus 1 into differentiation of the a plus j omega. Here we are doing differentiation with respect to omega. Then a it goes to 0. So here we are getting j. Is it? Next into j. So this is 0 here minus j by a plus j omega square. Here again it is multiplied by j. So j square equal to minus 1 minus into minus gets 1. Then the answer is 1 by a plus j omega square. So what is the answer? So directly write the answer is 1 by a plus j omega square. Next problem. Next Fourier transform here. Now one time only here multiplied. The next one is now t square into e power minus at into u of t. So means here we can write t into e power minus at into u of t. So that equal to so Fourier transform that equal to j into d by d omega of 1 by a plus j omega. Sorry, a plus j omega whole square. So for this case, we will get that t square equal to t square into e power minus at into u of t. Do that after simplification, we will get like this. So the answer is 2 by a plus j omega square. So 2 factorial. For the t to the power of 3, you will get like this e power minus at u of t. So here we will get 3 into 2. So that is 3 factorial by a plus j omega to the power of, sorry, here we'll get not power 2, here power 3. Here power 4. So from this concept, you can write directly in formula. So t to the power of n by n factorial or n minus 1, n minus factorial, you can e power minus at into u of t that equal to so 1 by a plus j omega to the power of n minus 1. Sorry, this is 1 by a plus j omega to the power of n plus 1. So if it is t to the power of n minus 1 by n minus 1 factorial, here we will get the power n. So this is the small correction. If it is n minus 1 by n minus 1, here we should write n. So these are the Fourier transform for the periodic and aperiodic in complete table. It's very, very useful. You should write in one table. It's very, very useful for your preparation. See, in previously taken like this. So these are the formulas for periodic. Here have period signal. Have taken here. So these are the problems in the continuous Fourier transform. In next class, we will go for the previous year question problems and basic problems asked in the examinations. Thank you.